Hello, Dr. Mike here. This is for my Python class, and this is a quick video about um, correlation and plotting. So this really does fit in with my Python for data analysis class, and it sort of fits right in between parts 1 and 2 for Iris. And I just want to tie some more concepts together and some code that help you um, bring help you sort of drive in and hone in on this two parts of this Iris data set analysis. So first off, there is a video where I talk about different correlations and covariance. Just a quick review. You have two variables, x and y. Covariance is if x goes up, does y go up also? If it does, then you have a positive covariance. This is covariance. And if x goes down and y goes up, if this affects y, then we have a negative covariance. Now, correlation, I'm just going to close that. Correlation, of course, is the test looking for association between the variables also. And just think about association between two objects, or two data elements. An example in this presentation here is miles per gallon versus weight for vehicles. So, of course, you can say, well, yeah, I mean, heavy vehicles probably get less gas mileage. So you want to prove that. So now again, I'm not going to get into that video. You have to look at, but we're going to look at Iris data set. So I'm going to import NumPy and Pandas. I'm importing NumPy as NP and Pandas as PD. I do have my Iris data set file, and I'm going to load my data set as main1. If you call yours something else, DF, Iris, whatever, just keep that in mind. If you're trying to follow along here, you can see I have, there is a sample of it. So now we looked at Iris in part 1 and also part 2. So I'm going to sort of bring these together into one topic here and show you what we need to do to go beyond just making a plot, but showing correlation. So first off, again, in Iris part 1, you need to create some data summary plots. Plots showing sepal length by sepal width and petal length by petal width. So, of course, one of the things you can do definitely here is close this out here. So one way to approach this is definitely you can create some groups, and we can do scatter plots. So scatter plots are great. They're built into, you can use matplotlib if you like, but we're going to come and look at Pandas. Actually has a scatter plot. And I'll just run it here. So I'm taking the main one and I'm running it into a group by species, and I'm sending it to a plot.scatter. I'm doing sepal length by sepal width. So sepal length by sepal width, and then do another one, and I'm doing petal length by petal length. So now I get this straight output here. There's no titles on it, and we know the first one's for Setosa, second one Virginica, versicolor, and then Virginica, and all the species are together. So it's probably not the best way to plot, but it's not a bad way to approach your analysis. This is maybe something I'm not going to put into a final report or presentation, but I just want to start. I want to start looking at this data and plotting it in different ways. Of course, I could do this. And this is how I actually approached this problem. Was I actually want to create a data set or a data frame from each species. So I create a data frame called Setosa, and I tell it, hey, take main 1, and where everything in main 1 is species equals Setosa, and equals 2 is double equals. Don't forget. In programming, a single equals sets, and a double equals is a comparison. So I'll create one for versicolor and one for Virginica. So again, I'm splitting this out into smaller data sets. And I'm going to do basically the same thing up here, but I'm just going to create a scatter plot for each of these things I need to do, sepal length and width, and petal length and width. And I'm actually going to give it a title. I'm going to run this here. So okay, now I got some better plots here. I can see this is Setosa, sepal length by sepal width by sepal length. So I could say, eyeballing this, there is a correlation here. It's a pretty loose correlation. You look at the petal, there's probably no correlation here at all. It's now again, our sample size is what, 50. It's 150 sample size. So we have a sample size of N of 50 here. Number of observations is 50. So not a lot. I would, of course, maybe want more, maybe 3 times that to really get a better idea. But for that data set, we can probably say, based on this data set, it looks like petal width and petal length are not correlated for setosa, or sepal width and sepal length is correlated. There's a sort of a positive correlation here. As one goes up, so is the other. And so the first part was to create these plots, explore and plot this data, right? It's basically by species, so it's 2 plots by species. And I'll show you a couple other ways we can approach this. And you can see the rest of the plots. So now, the problem is I just said what? I said I think, based on looking at this graph, there is a correlation. I'm going to show you some approaches with the part 2 here where we can actually do some more correlation analysis. So and if I want, I can create this matplotlib. Matplotlib, of course, I dig in a little deeper now. I'm going to import matplotlib as PLT. And I'm going to use a scatter plot in matplotlib. And I'm also going to do it within a subplot. So I'm creating subplots here. So I'm creating a figure with axis 1, axis 2. So I sort of use the matplotlib documentation as a guide here. And it did take a lot of copy paste, retype, a lot of errors. And you can see I'm doing a figure of axis plot 1 by 2. So 2 across 1 row by 2 columns. I'm getting a figure size of 21 by 10. This is just to make it larger. And here I'm taking these same plots. I'm creating the plots form. And I'm basically go ahead and plot those into here. And I add a legend and so on. So there's a lot of moving parts with matplotlib. But if you take the time and look at the colors and the backgrounds and so on, you can create these now. Again, so you can say, well, look at the petal length, width, and length by all species, especially setosa. There's a tight correlation here. So you can see there's a really nice correlation drawn across here. Well, this one is still pretty loose. Now, again, is this something I want to put into a final report? Something you want to consider here. If you're colorblind, or your audience has color blindness, you can see here you might just see 3 gray dots. So it might move from colors to shapes. So keep that in mind when you do the plots. You might want to use shapes instead of color. So, and there's a lot of options here. I don't want to get into it here. You can see the call out here and the collab. It's pretty nice. But yeah, definitely look at the scatter plots, and alpha might also help, and so on. So markers, which one to use. So look at markers instead, and then you can, of course, click on that. You can see if you don't use pixels, circles, triangles, and so on. So just keep that in mind if you have audience. I myself can see the colors, so I can see this, but right now, if you're watching this, you might not be able to notice that. So again, we can definitely use matplotlib on that. I do want to show you something else we have called Seaborn. Now, Seaborn, I don't teach in this class normally. I have another video where I think I show this off. But this is an example of if you want to go outside of matplotlib or pandas, this is perfectly acceptable, at least in my course. And I want to bring this in. So I would do is definitely add a note, maybe add a link to where you got it from. I myself, as a professor, like to see that. It's a way of sort of referencing where you got this library from. And 2, of course, if you share your code with other people, and unless you're gone, if they don't say where you got this from, they don't know where Seaborn is. Just a way to sort of document your code. So you can see I put the link in my comments here. Now, I'm going to import Seaborn as SNS, and where did I get that from? So you can look at the gallery if you like, almost like matplotlib, and look at the gallery and say, is there something here that I want to use? There's certain plots here, like this paraplot. I like this paraplot maybe. I want to use this because I can see, in fact, look at the species by 3. So I can plot all this stuff into one big graph with really one line of code. Pretty awesome. So we can see we have a data frame here called penguins, and then they have a paraplot. So I'm going to sort of use that code. And don't forget, you do have the, most of these pages have some sort of tutorials. They have documentation, like the software pandas, and we'll come back to that in a second. So again, I'm going to import this. I'm using a pair plot. I'm going to use that main one data frame. I'm going to do hue by species. And you get a fantastic, let that run. A really fantastic looking output. And this is something I might maybe consider in a report. There's a lot of information in one grid here, but you can then easily call out by eye. Again, maybe I don't use colors, maybe use symbols instead. And there's tons of options for all libraries to do that, but for now we can see petal length by petal width. There's some correlation there. Correlation between petal width and petal length, of course. It's really the same plot. So you're seeing the same data plot different ways. And of course there's a lot of duplicates. But still, it's a fantastic way to sort of canvas your data, throw it all into a paraplot, and just really look at it. And in fact, we see some distributions too. So Seaborn is a great way to approach this for any research. So again, the idea is I want to create these plots. Now you can do bar graphs, line plots, but the idea is you want to do by, and that's really the key here. So I want to compare two things, and if I did a line plot, let's do this. If I just do a regular plot here, oops, no dots here. If I do a regular plot, that's what happens. Looks like a first grader scribbled them. So just want to keep that in mind. Run your plots, and you go, this is not going to be helpful. Go to the matplotlib, go to the pandas plots, and look at different plots here. And you can look at getting started user guide and so on. So again, look at different examples, do some Google research. We can see that that did not come up very nice. So a plot dot scatter is what you want to throw inside there. Definitely much a lot more easier to look at. So that's just an example of making sure you sort of apply the right plot for the data and what you're trying to convey with your output. So that's sort of part one. Of course, you've already done this probably, and hopefully you've gotten some guidance on this. Again, Seaborn's great. Use Seaborn if you like. Part two. Actually, let's go ahead and rerun this one here again. Let's run this one. Maybe this is what you want to use. You can, copy these out or use these, or just, refer to them. So you can say the setosis sepal width by length. There is a correlation. Looks positive. Again, it looks positive. Now, when we come to part two of iris, we're talking about correlation. Correlation between sepal petal by species and sepal and petal length. So length and width, sepal and petal, and so on. So, and also how they're distributed. So let's talk about correlation. So first off, you can do correlation in NumPy. I'll just run this here. This is actually just creating two NumPy sort of variables here, and we can do a core-sef. So it's a correlation. That's the np.core-sef here. That's the parameter. That's a Pearson correlation. And you can see the examples there. What to use, correlation x by y. Again, there's a lot of options here you can look at. But what we've got here, of course, we see is 1-to-1. Well, of course, if there's a correlation. There's a one correlation between the variables here. But what we're looking at is variable 1, variable 2. There is a 0.35 positive correlation. So, or I'm sorry, 0.335. So rounded up 0.34. So 34% correlation positive between variable 1 and variable 2. Again, I don't want to get too much more into NumPy. It is there if you want to use it. But I want to talk about pandas. So pandas has a correlation, and it's .core, C-O-R-R, 2 R's. And you can see the method. You can pass in the method here. We can do Pearson, Kendall, Spearman. I have a thing where we talk about that, so I'm not going to get into those. Most of the time, you're going to use a Pearson correlation, especially if you're dealing with measurements, weights, things that are a continuous data. So it works great for this. Go back to here. So I just do .core. I just run it on my main one. And right there, I get a nice little output. Well, of course, you can see sepal length by sepal length is 1. It's the same exact number. So again, you get this sort of 1.0 correlation across the axis here. If we look at sepal length by sepal width, we can look at correlations. Now again, there's no grouping here though. So we can see by species, which we're not doing here. So we haven't done by species yet, but still I can at least throw the correlation down, start to get a feel for what we're looking at. Chances are, because the number of observations is 150 total, 50 per species, these might still roll over. What we could do is this. We can actually say, you know what, take this main one data set and take the petal length and correlate it with petal width. So we can be more precise here, and then we get this. And if I want to even take it even further, I can go ahead and say, take Setosa, and basically just copy this. Setosa. There we go. Before I run that though, you can see now we're just taking, we were saying, yes, these two individual variables here, petal length by petal width, there is a positive, there's no negative in front of this, so there's positive 96% correlation. So definitely a strong correlation there. Now again, by species, you can run this here. And now we can actually see, well, there's a 30% correlation for Setosa. So we can take that, and we can do, what's it, Virginica, the other one? Say versicolor. Copy paste is your friend. And now we have a stronger correlation, 0.78. So the point I'm making here is we can make graphs, and plots are great. If I deliver a 0.78 correlation to someone who has no idea what that means, they might go, okay, what does that mean? I can say 78% positive correlation. They go, okay, I think I still, makes more sense now, 70%, but still what does that mean? So I can take this along with my graph. So this is for a versicolor, petal length, or petal width. So versicolor, petal length, or petal width. And say there's a 70% correlation here. And again, visually, it looks like there's a lot of outliers here, but there's some correlation. But let's take one that's got a entire correlation. Versicolor, petal, no, that's it right there, petal length, or petal width. So we can take this graph, and we can say, here's a graph of the correlation between versicolor, petal width by petal length. And it currently is running at a 70% correlation, positive correlation. So we're tying a mathematical correlation with a visualization, and that's what I want to come down to and bring that to you like that. So that's a great way to sort of wrap up. That's how we approach Irish Part 2. Is we want to visualize it first, and then Part 2 we want to actually bring some mathematics to it to positively show our correlation. Distribution. We have histogram. I'll just say this. There's always look at distribution. Of course, you can definitely look at Seaborn. There's a lot of stuff here. We can look at pairwise data relationships. We can look at distributions. I don't want to get more into Seaborn. That's NumPy's correlation coefficients measurement. We'll just close that there. What we can do though is look at histograms. So histograms are a good representation of distribution of data. Bam, so right there. Again, there's other ways you can approach this, bar graphs and so on, and definitely explore that, what you like. I just want to show you probably the most impactful way is to draw a histogram for this. And I can just go ahead and say take that main one and use a group by. Group by is your friend here. Group by is great. Group by is a great way to sort of group those species together, and we can plot it. And cool, we see sepal length, sepal, here's frequency. Again, now there's no titles on these, but I might just use these just to visualize it. But I'm going to show you something here. I'm going to have a note here saying add alpha. If we look at histograms, there's a lot of options we can do with our histogram plot. And one of those is alpha right here. And you can see in this example on the web page, if I didn't have alpha on, I wouldn't know 2 has this branch here if 1 was overlapping it. So let's just take that alpha equals 0.5, which is a good way to start. Let's put that in our histogram. And now you can see here, these little tails, they overlap. So it's an easy way to sort of view the data. Again, these are colors, so these might not be my final output. Like see Setosa is the first one, and so on. Virginia versus color. And I'm sure there's a way to put a title inside there. But of course, we can also do the same thing. We say, you know, I like the histogram, it looks great. I want to do it just with Setosa only. So using those data frames I created that were split off up here, way up here, I'm sorry, where I basically created a Setosa data frame, a versus color, and so on. I can go ahead and it's the same thing. I can apply that here. Now I did add something else too. I added something called figure size, 10 by 8. I'll show what that does. Makes it big. So look at fig size. You can also fig size will help you. It's on the keyword arguments here and our plots. So fig size, where are you? It's in here somewhere. It's a keyword argument you can pass into your plot. So figure size though makes it larger. If I didn't have it inside there, it'd be the same size. Again, this is probably fine, but now I actually have Setosa. Now I can probably put title equals Setosa, and I can maybe put some information inside here. But now I can see distribution. I can say, yeah, look at this distribution of sepal length is, you know, we have a bar distribution versus petal width is very, very tightly coupled here now. Think about histograms. The default bins, something to consider. The bins are a number of sort of how we say, you know what, we're going to take, we have all these different numbers, we're going to create bins of 1 to 10, 11 to 15, maybe 11 to 20, and 21 to 30. And we're just going to count how many fit each bin. So the default's 10, so you can actually explore with bins if you like. Bins equals 20. And see how it changes the output. So creating more bins, we sort of create smaller buckets to put the data in. I put bins equals like 50. Now we get this. Now that's actually, no, you can see that there's a little more up and downs here. It's a little more ragged, jagged. So again, if I do bins of 5, you probably notice I'll put big blocks of nothing, right? Because we created some 5 bins. So take the total max and divide it by 5, and that's how many bins you have. So again, the default's 10, but feel free to explore the number of bins if it helps. This is pretty good because we do see some data here, and there's all kinds of options for overlaying averages and stuff. But again, think about your output. You don't want to put too much on one graph. So anyways, histograms is a great way to approach the distribution question. Which is our last thing, how the sepal lengths distributed. Now again, sepal lengths. So again, I'm doing full distribution here, so what I might do is pull out, like I did in other areas, get sepal length. So let's grab that. Histogram, Setosa, and what was that? Want sepal length. Sepal. So we should be able to call out right there. So that is sepal length. So I can probably make a title on there if I wanted to. I think it's just our figure graph. I think it's its title. The uppercase title. Nope. In any case, for the documentation, I like to hover over. I can look at the parameters. If I get this figure size, the alpha, my plot, there you go. So I can look at the kind, plot histogram, so on. Title for the plot areas. So it's like title. So again, you can add title, Setosa, so on. Setosa sepal length distribution. And I'll add that there. Again, I might mess with the bins maybe. You can see there's a lot of raggedness here. Go back to the default bins of 10. That's pretty good. So we want to even decrease it. again, that's almost a regular distribution there, pretty much average, right? Our bell curve. So a lot of things to explore here. I sort of went over a few minutes here. I wanted to. You can see where you can explore these. So there's not a lot of graphs to create, but there's a lot of depth you can create with the graphs. And the correlation itself, look at your pandas correlation.core. And again, if you want to explore any third-party libraries, feel free to do that also. So again, this wraps up just sort of a in between Iris Part 1 and Part 2, and hope it helps out. Thanks for watching.